Hello everyone, good morning, good evening, wherever you are, whenever you're watching this. So, my name is Krishna Vamsi. So, I'm currently I'm undergoing my PGD program in data science through upgrade. So, this particular capstone project is related to my PGD program. So, like this video is to go through the capstone project which I have done. So the capstone project picked by me is the credit card fraud detection. So in credit card fraud detection, first we have an initial analysis where we have a brief overview about the business problems. So in basic terms, it's nothing but we need to detect the fraud transaction well in advance before even the transaction could happen. So it is like in a matter of seconds. So for that to happen, then we need to have a proper model where it can detect a pattern and maybe like it it may just intimate the user or the bank saying that this particular transaction may be a fraud transaction. So the basic bank requirement is they do not want to go into losses because based on a fraud transaction uh, because see, when a customer a fraud transaction happens through a customer's card or customer's account, so the customer will not be willing to pay the money he lost due to fraud transaction. So that money needs to be repaid by the bank itself to the user or the customer. So it's ultimately the loss of the bank which happens at the end. So if the bank does not repay back the money, then uh, the bank may lose its well-known customer. So yeah, the business requirement is to create a machine learning model which can detect a fraud transaction based on the pattern or based on the pattern on which the transaction is happening or based on the details on which the transaction is happening. This would help the bank grow financially and also attract a lot of customers. So coming to the data set, so I was provided a data set from from a third party website called Kaggle. So in this particular website, I have two data sets. One is the test and one is the fraud train. So I picked up the fraud train data set because both the data sets are almost similar and this particular test is only used for testing my model. So coming to my PyCharm code, uh, not PyCharm. So my Python code which is done using Jupyter. So initially I'm importing all the required libraries, then these are few default options. Then in the initial part I'm trying to read the data. So in my case the data is in the same location, so that's why I'm directly reading it. So I'm just here I can this is the raw data which I'm displaying. So it consists of almost 20 around 20 columns approximately. So checking all the data types of the columns and also checking whether the data is free from any kind of nulls and also any kind of duplicates, just trying to uh, do few data frame operations here so that I can verify my data. And this particular describe, this is used to get the mean, standard mean, minimum and the percentile. So this is generally used for looking for outliers, if the value is too high or too less, then we need to handle it. Coming to the exploratory data analysis, currently initially I checked with the fraud column. So as this is the training data set, so we only have 7,000 fraud records and also initial null check and also handling the outliers. So before handling the outliers, I'm looking a brief into the outliers diagram so that I can understand. So this particular box plot gives an overview about the amount. So like amount can range like from minimum to maximum. So like as you know, like if there is any 100 rupee or 200 rupee transaction, you do it regularly. But if there is some big transaction, you do it rarely. But that particular transaction, the chance of happening is is like present. Like within like in a month, a person may do a big transaction. And also like I try to do a distinct on the merchant details, but this is too huge and this is of no use. So just like I kept it here so that I have done it. Like this is small visibility, like I have done it or not. Yeah, but this graph can explain a lot, but this merchant details are not for you. So then I uh, used a bar plot to understand the category level data information. So like yeah, as you can see, the transport and the groceries, the credit card transaction happened for transport and groceries is much more. So then we need to like find like where a fraud transaction can happen, and also like based on the city population. So this also does not come into like this city population is also not used to, does not play much role in predicting or designing the model. Then like I was inspecting the target variable, the ease fraud variable using a pie graph. Then I was trying to find few patterns between the amount category and the time. So like this gives few insights. The first one, I think it's of no use. The second one, third one, yeah. This gives a brief insight like how the data is scattered, how the money is scattered. Then after that, like I'm trying to create my training set. So I dropped the unnamed column 0. So this column is of new. This is just a default column. So then like I used the transaction date time. So like I converted it into date time so that I can extract the year, month, and date of from that particular date value. So also like so yeah, I also used the same date value to find the day of the week. So using the function called day underscore name. So this gives the day of the week, like on which day like the transactions has happened. So yeah, this can also give a brief insight like based on the day and the time. Like there can be cases where people can be like less active during Mondays, Tuesdays, during the early hours. Yeah. So like in Saturday or Sunday, people might be using credit cards, so they might be aware of how much they are using. Yeah. So that's why this is also important, and also like I try to pick up the year and month, which is also helpful, and also transaction hour. Then I used few uh, bar plots to like plot it here. So yeah, the similar way like I represented like I have like created a presentation here also. This is nothing but the same thing which I am explaining over there. Just return it here. Like the words which I say are written here. Like I was trying to observe different combinations, yes, and also the requirements for model building. Yeah, this is the place where like I was extracting year, month, and date, and also a bit of more analysis and observations. Yeah, so here like I found out that like highest number of transactions happen in the month of December, and lowest number of transactions happen in February. And this is expected because the number of days are less in February. Female customers are using credit cards for the transaction. This is also because the female customers count was more. So yeah, this was also one of the observation. This particular bar graph is to like check the age of the customer who is using it. So the minimum is 14 to 96. Like people older also use credit cards. So this is the percentile distribution just to have a like outlier information, the minimum, maximum, and the 50% to 95 percentile. So this is also like represented here, as you can see, and this is a small distribution between the fraud and non-fraud amount. So this is the amount distribution. This is the non-fraud amount distribution. Yeah. So this is the fraud amount distribution. As you can see, like it ranges somewhere between 200 to 500, or it will go like it will come under the bracket of 800 to 1000. And after a bit of analysis, so I was trying to uh, check the number of fraud transactions per month, like number of fraud customers and fraud transactions. Maybe this data might be useful. And also, yeah, see, as you can see, female count is more. So based on this insight, we came up with the conclusion that females also use credit cards, like not not to like I think feminist. Like I'm just saying that females use more like more more prone towards using credit card. So yeah. So this is for based on the category and the number of transactions we are trying to detect the frauds. So yeah, as you can see, the fraud transactions are much less. This is for a, I think this is for a category and fraud. Yeah, for a yeah, this is for a category and fraud. Yeah, number of transactions are more in travel, grocery net. So here, yeah, as you can see here, like the fraud transaction is nil. So the fraud transaction does not happen at this category level. Only it happens like this. Yeah. Okay. Yeah. So it's so sorry. Like it happens at like both the category, like all the categories. So this is for the travel category where the fraud does not occur, and this is the count. And see, this is the category, the same category where fraud occurs and its corresponding count. As you can see in this, like grocery has a law like more amount of fraud transactions. So here we are using the merchant value just to check the percentage. So so yeah, here based on the merchant type we are trying to check the fraud transaction and the number of transactions. Yeah. See. So for this particular merchant, like there are more number of fraud transactions. So yeah, so I tried to use a logistic regression model. So that's why like I'm one hot encoding the categorical values, as my dataset mostly consists of categorical values rather than numerical values. So that's why I'm using one hot encoding so that I can give a default value for all the categories. Like I can use the categories for my logistic regression models. So yeah, so the columns which I picked for training my data is like it would come afterwards. So first I like tried to check the number of transactions made by a customer within 60 days. Like here you can see like for a credit card number for first month he does not have any transactions. Like when he goes down the line, they are increasing. Yeah, this might be useful. So if you see like in within 24 hours, like it varies, but uh, this particular analysis or this particular 24-hour concept, like it may like vary our model. Like the model may does not behave well like if it has like hourly transactions, because they are not like in a proper pattern which happen regularly. So here, yeah, based on the job type, I'm trying to see the transaction count and the percentage. So yeah, so where film or editors use the highest number of, like they do the highest number of transactions, and compared to contract civil engineer, they are like they do very less number of credit card transactions. So yeah, this is for film editor, like number of fraud transactions are 44 and like proper transactions are 9,000. This is to like check the percentile in the percentage group. So this is also similar. Just we are ordering it by alphabetical order. Yeah, so here we are importing the model selection training script. So here, as this data is highly imbalanced, we need to have a balance this by oversampling. So like I have a source code for oversampling. This is the data, how it looks, and then the columns which I used for training are all these columns. I mentioned these columns here also. And yeah, so this is the place where I'm training the model, and also like I'm predicting it using the logistic regression. So yeah, so as you can see, the precision and confusion matrix is here. So like I show it here also. Yeah. So coming to the accuracy, the training data accuracy is 92, recall is 74%, testing data accuracy is 93, 83, sorry, recall is 74%, and yeah, these average number of fraud transactions from these are used for me to like fill up the cost benefit analysis. So I use the same data frames. I use the data frame results to find the fraud transactions count. Yeah, so these are few mathematical operations which happen here, finding the general count and all. So here, yeah, average for number. These are the total number of transactions per month. So these range around 4 lakh, and average number of fraud transactions per month. These are like 2,000, 20,000. Sorry. So this is the average amount per fraud transaction. So this is like 500 or 530 rupees. So so here you can see, so cost incurred, this is nothing but the multiplication of B and C. So this is around like almost 6 lakhs, it's around like 1 crore, like if you consider it in a whole year. So average number of transactions detected per month by the model is 400. So if we need to intimate this to the customer, so we need to have a support, customer support executive to inform the inform the customer related to the fraud transaction. So that might cost like $1.5, so multiplied by these two, so the total cost will be $600. So this is the average number of transactions that are fraudulent but not detected by the model. They are 100. So this is the cost incurred due to fraud transactions which are not detected. So it's approximately $50,000. So this is per month combined. This is also loss which goes to the bank itself because they need to spend some amount to intimate the customer. So adding these two is the total investment which bank needs to do, uh, like the cost which is bank needs to pay. Like this is the cost incurred per month after the model is built. So like I try to minus it with the cost before which the model was deployed, the cost incurred. So this is the final savings. It's like approximately like we are losing out 50 or 60 odd dollars if the model is like very much accurate. So coming to the, yeah, so these are like 5 W's and how. So this, yeah, sorry, this needs to be like brought up in the early part. So this is not like, so this is like who is involved in the process. So customers and the banks is involved in the process. So the fraud happened first to the customer. After verification, bank needs to repay the amount. Yeah, they use loopholes and different methods and payment gateways. Yeah, that's also true. Where do the transactions happen? Sometimes they happen online. Sometimes it happens offline. It depends. Like we are not sure. Like it happens at a particular place. So it can occur during irrelevant times when the customer is not active. So how the business is affected? So people may not be inclined towards this bank or opt a credit card in this particular bank as the number of frauds are more. Like whenever a customer wants to apply a credit card, he like checks all the stats on how the banks and its corresponding credit card and securities. Yeah. So that's the effect of the credit card fraud. And also, yeah. So this is the toggle diagram. So this is the general diagram like which was provided by the which is provided in the assignment. There were few gaps which I needed to fill. One is this personal credit card details with various authentication options. So this is one of the reasons. So yeah. So few people do not have visibility over bank transactions. So this is for when the bank is not able to identify and customer and it does not bring and the customer does not bring the fraud transactions to bank's notice on time, that there is a reason behind that. Like few people does not have visibility over transactions. Most of them like try to check afterwards or later when they like feel free to, or like when they feel to check, or when they want to do some calculations, yeah, that time people might check. So that's why like they don't bring in the transaction to the bank's notice. So yeah, so few banks do not have proper tools to identify the pattern. That's because they do not use fraud detection and machine learning techniques. And sometimes proper transaction updates are also not received in decent time. That's also a reason. Yeah. So yeah, ATMs and POS terminals do not have OTP systems available. So yeah, that's why people do not be aware of a transaction happening at that particular case. Yeah. So thank you so much. So hope like I have like covered most of my details uh, in the Capstone project. So currently I'm moving ahead with submitting my Capstone project. Yeah, like Upgrade was a great platform, collaborating with IIT Bangalore professors for giving me opportunity to understand, and also the UI was user friendly. It was not uh, too heavy or not too much for a like student or a working professional. This particular presentation is pretty much decent. So yeah, thank you so much. Goodbye.